Well, hi there. So in this video, we're going to be taking a look at some of the extra practice problems for Unit 3. And this is a little bit of a change from previous units, but I've gone ahead and actually taken the questions that are from the textbook that I've assigned for you as extra practice, and I've created a Google Doc for them that allows you to kind of write on the sheet. If you'd like to print that off, that's available on Google Classroom, and you can check that out and find it in Classroom. But otherwise, we're going to be basically doing the same problems that are available in your textbook, and you're welcome to do those still on homework paper, like lined paper or blank paper, or if you wish, you can print these out and then you can actually work them on here. So it's a little bit more smooth in terms of being able to see what we're working on. So let's get started. The first extra practice module is about module 54. It relates to the production function, and there's two problems here, one about Bernie and an ice making problem, and then a second problem down here that asks you to graph a production function. At the end, we'll take a look at the multiple choice practice. So Bernie's ice making company produces ice cubes using a 10-ton machine and various levels of electricity that are kind of labeled over here, 0, 1, 2, 3, 4 kilowatt hours, which I think that's a little on the small side, but whatever. We'd say that the quantity of output in pounds of ice is given along out here. So these are total product and this is total variable input. And it says for part A, what is the fixed input? Well, that would be the machine, the ice machine, and the is the fixed, we'd say fixed. And we'd say the variable input is this electricity, because it can vary, and so we'd call that the variable input. We assume that probably Bernie has a worker, but he might be the only one, in which case he's not really a variable input. But if he had workers, you would probably say that the labor input is also variable. But in this case, it doesn't tell us that. B, construct a table showing the marginal product for each level of the variable input. At which level of electric does it show diminishing returns? So we're going to put that table here, although it is right up here that we could kind of just do this from. And we'd say Q input, and then the marginal product, which is kind of what we're looking for. So 0, 1, 2, 3, and 4. And then these marginal products are going to be the change in the product generated from an additional unit of input. I'm going to zoom in just a little bit on these, hit focus. Hopefully we can see that. There we go. And so this change for the first one, there's no 0th amount of marginal product, but for the first one, they gain 1,000 pounds of ice. Then when we move to the second one, they gain 800 pounds. Then the third one, they gain 600 pounds. And then the last one, they gain 400 pounds. And so we would say, does it show diminishing returns? Yes, in all range. In the whole range, it shows diminishing returns to the input. If we had gotten maybe an increase and then it starts decreasing, you could say maybe from the range from Q1 through Q4. I suppose from Q0 to Q1, they have an increasing amount of that input. So it really doesn't demonstrate it when we go from 0 to 1. But everything subsequent to 1 is a decreasing amount of marginal product. So we would say that yes, it does. Question C says, suppose their firm buys a 50% larger ice machine that increases output by 100% for any given amount of electricity. Construct a table showing the new quantities of output and the marginal product for each level. And so here, quantity of input, we're going to have the same 1, 2, 3, 4. And then our total product and our marginal product. Well, it says it's 100% more output. And so at every level, we're going to just double that. So it goes from 0 and still doubles to 0. But 2,000, 3,600, 4,800, and then 5,600. And so what I'm doing there is just doubling the amount of output every single time because it's 100% more. And then the marginal products are themselves also going to double from what we saw before. Whoops, that's 1,600, 1,200, and then 800. And again, the kind of two ways that we could do that is obviously the rate of change in between these, but it's also just doubling the amount of marginal product because we've actually increased basically that by 100%. And for what it's worth, that 50% larger ice machine, well, that would just be like a 15-ton ice machine. I guess it can make a lot more ice. All right, our second problem is use the data to graph a production function and the marginal product of labor. Do the data illustrate diminishing returns to labor? And so what we'll kind of do first is just off to the side, I'm going to calculate their marginal products. 19 for that first one since it's going to the 0 to the 19th. And then 17, and then 15. I'm just doing these in my head and hopefully they look right. 13, 11, 9, and then that's 6, that's 7, and 5. So they're going down by 2 every single time. We would say if we're going to graph it, kind of do a nice sketch here, quantity of the output. For a production function, it's the relationship of inputs to outputs. And so actually, quantity of inputs, and then we do quantity of output up here. And so we'd say, what's the maximum amount of output is 100. I mean, really it's 96, but that's pretty close. We go 1, 2, 3, 4, 5, 6, 7, 8, and that's the 8th. 2, 4, 6, just kind of labeling a couple of choices here. We obviously have 0 and 0. I'm just going to kind of pick some intervals here to kind of roughly sketch what this graph's going to look like. It doesn't have to look pretty, but just kind of roughly what it's supposed to be here. And the first one I'm going to do is the total product function, which is basically the quantity of input, that's the labor, to the quantity of output. So 1 and 19, that's like there. 2 and 36, somewhere in there. 3, 51, right there. 4 and 64, there. 5 and 75. 6 and we'd say 84. 7 and 91. And then 8 right up here at the very top, 96. So we're kind of getting that look to it. It's a little bit, a little wonky. Probably if we had the 9th worker, we'd end up seeing going down again, but we don't know if that's actually going to happen. We don't know if that downward slope would occur because probably this firm wouldn't end up hiring that additional worker. We wouldn't want them to do that. Based on our data, that probably occurs at the 10th worker. Then we can do the marginal products. So we'd say 0, and there's like the 0th unit. Going from 0 to 1, the marginal product is 19. And then from 17 for the next one, and then 15, 13, we're going to keep like going down, 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 really, really small. And it should just be this kind of straight line. I'm not really perfect on that straight line, but realistically, what it's going to really look like is if we did one of these, woo, like that, and then just like that. Move that up just a little bit. So it should actually look somewhat like that, because this is our marginal product function, and where that crosses, where marginal product equals 0, like where that next worker that generates no marginal product would be, that would be where our total product is maximized, because that additional worker of input, because this is our input axis, as we're increasing our inputs, we're getting less and less out of each one of them as we increase total product until we hit a maximum of total product, and that's where marginal product hits 0. All right, so here we'll take a look at the multiple choice. So for the multiple choice practice for these, again, they're the same multiple choice questions that appear on the quizzes. We'll just take a look at each of these and solve through them. Production function shows the relationship between inputs and outputs. We just talked about that. We constructed one. What defines the short run? We learned that that's when there's at least one kind of fixed input. And the idea here is that you have a fixed input that tells us that like you're operating within a time frame where there's something that you can't change. So we call that the short run. The long run is where they're all variable. The slope of the total product curve is known as the marginal product. It's also the derivative. So we have these two functions that we just constructed. This is kind of the slope of it. And that idea of saying like, well, that's the reduced amount basically by every single time. It's the rate of change. Diminishing returns to an input ensures that as a firm continues to produce, the total product curve will have what kind of slope? And so we know that it's going to be like up and then come back down. And usually this part is a little bit kind of steep, and then it kind of flattens flat, and then it hits a max. And what they're really kind of referring to is what's going on in the second range. So it's probably better to draw that curve like steep, and then it starts to flatten out. And so this range is where the diminishing returns to the input is actually occurring. We know that there's negative returns to the input over here, but we wouldn't end up producing there. This steep increase is because of, obviously, there's gains from specialization. But this flattening out is occurring because of this idea of diminishing returns. We would say that this is still an increasing, or this is a positive slope in the sense that it's still going up, but it's a decreasing rate. And so we would say positive, but at a decreasing rate. That's B, just don't take care that it's diminishing returns. Historically, the limits imposed by diminishing returns, well, they've been alleviated by more capital. That would be A. So we've got for these D, E, A, B, and A. D, A, D, A, B. There. Hopefully this helped you. I'll see you next time.